this video, let's learn how to solve for y in this nice exponential equation. Can you solve for y in this expression? Don't forget to give this video a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified mathematics content. Now, if you look at this equation very well, you'll notice that they all have a base that can be turned into a common factor. That is a factor of 3. Now, if we are given all that, we can simply put all of these into a common factor. That way, we can easily solve this expression. So we'll have all of them driven to a common factor. 3 to the power of y plus 3 to the power of 2, and this will be all to the power of y, and this will be equal to 3 to the power of 3 all to the power of y. Now, what do we have in this expression? How do we break this down? Now, I want you to recall a law of indices. In that law of indices, if I have a to the power of x all to the power of y, this can be equal to a to the power of y all to the power of x. That's the change of exponents. Now, if I change exponent from our initial expression, we'll have 3 to the power of y plus 3 to the power of y, all multiplied by the exponent 2, and this will be equal to 3 to the power of y, all multiplied by the exponent 3. So we have one common term. And what is the common term? 3 to the power of y. So what we are going to do is to assume the value of our x to be equal to 3 to the power of y. That way, we can simplify this expression simply. Now, if we have the value of x, this expression will now give us x plus, this is going to give us x squared, and this will be equal to x cubed. Great. Now, let's simplify this by bringing all the parameters into the left-hand side. If we do that, we're going to have this to become negative x to the power of 3 plus x to the power of 2, and this will be equal to 0. Well, it's not pleasant having the cube root of x, the cube of x to be negative. So we are going to multiply all through by negative. So we'll have x to the power of 3 plus x to the power of 2, and all this will be equal to 0. We're going to multiply this by a negative sign. So if we do that, we're going to have that expression to now give us x to the power of 3, because negative multiply negative will give us negative. This is going to give us x to the power of 2, and this is going to give us minus x, while this will be equal to 0. Great. So having rearranged that, what we are going to do is to simplify. Now, looking at that, you can see that these all have one common term, x. So we are going to bring out x. Bring out x, this will become x squared minus x minus 1, and all these will be equal to 0. And this serves as the zero product rule. So in the first case, we are going to have the value of our x to be equal to 0. So that is a solution to that expression. In the second case, we are going to see the value of x squared minus x minus 1 to be equal to 0. And this is a quadratic expression. So to get the other two solutions, we are going to solve this quadratic equation. Now remember that this quadratic expression is similar to ax squared plus bx plus c, and this is equal to 0. So from that expression, comparing those two expressions, a is 1, b is equal to negative 1, and then c is equal to negative 1. So we're going to use the quadratic formula in finding the values of x. But before we find the value of x, the other two values of x, given this quadratic formula, we'll see that x is equal to negative b plus or minus square root of b squared minus 4ac, and all these will be divided by 2a. So we're going to find other two values of x. Now remember that we said a value of x is equal to 3 to the power of y. So the main aim is to find the value of y. But let's first of all find other two values of x, and then we can find the values of y. So we're going to assume that this is x1. So the other two values of x we are going to have by inserting these a, b, and c into the expression. So we'll have x will be equal to minus times minus will give us 1 plus or minus the square root of negative 1 square is going to give us 1. Minus times minus will give us plus. 4 times 1 is going to give us 4. And all these will be divided by 2. Great. So we're going to consider looking for the value of x. The value of x will be equal to 1 plus or minus the square root of 5 divided by 2. So we're going to have this to become x2 to be equal to 1 plus the square root of 5 divided by 2, and then we'll have x3 to be equal to 1 minus the square root of 5 divided by 2. Now recall that we have a value of x1 to be equal to 0. Great. So we're going to find the value of y. Recall we are asked to find the value of y because x is equal to 3 to the power of y. Now from the value of x1, if x1 is equal to 0, and we say x is equal to 3 to the power of y, so that means 3 to the power of y will be equal to 0. 3 to the power of y will be equal to 0. So to find the value of y, we're going to take the log of both sides. So if we take the log of both sides, we'll have the log of 3 to the power of y equal to the log of 0. So the log of 0 will be equal to, if you click type on computer, is going to give you error. So that means if we can't find the log of 0, this solution remains what? An undefined solution. So we're going to find the value of y following all other solutions of these other two. Now we are given the value of 3 to the power of y to be equal to x. So if we consider x2, we're going to see that x2 will be equal to 3 to the power of y. So to find the value of y, we're going to consider the value of 3 to the power of y to be equal to, that will be equal to the value of x2, 1 plus root 5 divided by 2. So we're going to take the log of both sides. If we take the log of both sides, we're going to have the log of y base 3 equal to the log of 1 plus root 5 divided by 2. So if we simplify this, we're going to have y log 3 to be equal to log of 1 plus root 5 divided by 2. So what do we have here? We're going to divide all through by log 3. If we divide all through by log 3, we're going to have this to become log 3. So log 3, we'll have to clear log 3, and the value of our y will be equal to log of 1 plus root 5 divided by 2, all divided by the log of 3. Now recall one law of indices, that if you have log of A divided by the log of B, this can be equal to the log of A base B. So from that expression, you see that the value of our y will be equal to log of the base this time around is going to be 3. That is going to give us the log of 1 plus root 5 divided by 3 base 3, and that is the value of y that is originally given to us. So if we check this solution, you're going to see that the value of x of y is going to be the log of 1 plus root 5 divided by 3 base 3. So let's look at the third solution. From the third solution, x to the power of 3, you'll find out that x base 3 is equal to this. Now for every value of, if we put the value of x to the power of 3, x base 3 equal to 1 minus root 5 divided by 3. Now, if we take the value of x to be equal to, remember x is equal to 3 to the power of y, then we can find the value of y. So that expression will give us 1 minus root 5 divided by 3 equal to 3 to the power of y. So for every value of y, equal to 1, 2, 3, 4, this expression will always be positive. And this expression, because the square root of 5 is equal to 2.2, this expression will always remain negative for every digit we find here. So that means negative cannot be equal to positive. So as a result of that, we're going to neglect the solution that will come from x base 3. So the only solution we have for this expression is y equal to log of 1 plus root 5 divided by 3 base 3. And that is the solution to that exponential equation that is given to us up there. I know you did enjoy watching this math solution. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to our channel for more simplified mathematics solutions. Thanks so much for watching, and bye bye for now.